In this video and in the next few videos, we are going to take a look at infinite limits. So let's jump in with an example to try to explore what we mean by infinite limits. So here we're going to consider the limit of x over x squared minus 6x plus 5 as x approaches 1. And we want to consider this limit both graphically and numerically. So let's first draw a graph of this function. One thing I might observe is the denominator of that function, it would factor into x plus, x minus 5 times x minus 1. So we'll factor into this. If we tried direct substitution, we're going to get 0 in the denominator, but in the numerator, we're going to get something that is not 0. That suggests to me that maybe we're going to have an infinite limit. But let's finish drawing this picture, or start drawing it and finish drawing it. So at 1, so when our x value is 1, there's going to be a problem. 2, 3, 4, 5. Also at 5, there is a potential problem. And what we will see at both 1 and 5 is there are going to be some vertical asymptotes. If we were to draw this graph to the left of 1, we will have something that looks like this, maybe. Between 1 and 5, it's going to look something like this, and past 5, it's going to look like this. Now, as we look at this in the long run, we can think about what's happening. Some of the specifics on that, maybe those are not quite going to be right. It looks like if I plug 0 into this function, so when my x value is 0, it actually should go through this point 0, 0. So that first line isn't quite right. It's probably going to actually do something like this, maybe. But we have our picture. As we approach 1 from the left, of that function, x over x squared minus 6x plus 5. As we approach from the left, what's happening to our y values? What's happening to the function values? Well, they're growing. They're growing really, really big. They're not slowing down. They're just heading off towards positive infinity. Right? So as we approach 1 from the left, this just grows without bound. The closer we are to 1, the bigger the number is going to be. And if we approach 1 from the right-hand side, then we get negative infinity. Right, so as we get closer and closer to 1 from this right-hand side, our values are getting smaller and smaller. The closer we get to 1, the more large negative value we have if we are just to the right of 1. So the limit there, the limit as x approaches 1, we would say that limit does not exist. DNE does not exist. All right, so that's looking at that limit graphically. We can see that picture. It makes sense that this is getting really small without bound. This is getting really large without bound. Those two values are not the same. That limit does not exist. Another way that we can do this is we could look at this numerically. So let's look at it numerically. Remember, when we say numerically, we mean we're going to create a table of values. So we'll have a table of values for x, and then for x over x squared minus 6x plus 5. And instead of, and we're going to take values that are getting really, really, really close to 1. We'll pick values that are a little bit smaller than 1, and also values a little bit bigger than 1. So values a little bit smaller than 1, we could have 0.9, and 0.99 is a little bit closer, and 0.999 is closer still. At 1, we don't know what's happening. And then we'll pick values bigger than 1, so we'll go 1.1, a little bit closer, 1.01, and closer still, 1.001. We're going to see what happens to these function values. So we're going to plug in 0.9. We're plugging that in here, right, plugging it into our function. When we plug in 0.9, we will get something like 2.195. You should go through on your calculator, verify that you get the same value, make sure that you understand how you get that value. Then we'll plug in 0.99. We get 24.688. Plug in 0.999 and you'll get 249.69. Right? And so as we get closer to 1 from the left, it doesn't look like that value is settling down. The function value does not appear to be settling down. In fact, it appears to be getting larger and larger and larger in the positive direction. Let's look at the other side of that. So start with 1.1. Plug in 1.1 and you have negative 2.821. Plug in 1.01 and we get negative 25.31. Plug in 1.001 and you'll get negative 250.3. And we see as we're getting closer to 1 from the right-hand side, that number appears to be getting very, very small in the negative direction. Right, that's how we might deal with some infinite limits. Let's look at another example where we have something a little bit different that happens. In this example, we're going to take a look, both graphically and numerically, at the limit of 1 over x squared as x approaches 0. So this graph at 0 is going to have a problem. We can't do direct substitution. And this is what our graph looks like there. So as our function approaches 0 from the left, then what's happening? Our y value is growing without bound. It's getting larger and larger and larger. It's heading towards infinity. As we approach 0 from the right, then that is also heading towards infinity. So what we will write, because these two things are heading towards the same thing, they're both heading towards positive infinity, we will say the limit as x approaches 0 of 1 over x squared is equal to infinity. Now, you might say, oh, great, so this limit exists, the limit is infinity. And I would say, that is not quite right. When we say the limit is equal to infinity, we are actually saying the limit does not exist, but it does not exist in this very specific way. Right? So it is heading towards infinity from both directions. Right? So this limit, even though we will write that it's equal to infinity, this is a specific description of some limits that do not exist. So this gives us a little bit more information about why it does not exist. And so we'll just write equals infinity or equals negative infinity when they are approaching infinity or negative infinity from both sides. Right? Now on the previous page, the one that we looked at, when we approached from the two different sides, they did not settle in on the same infinity. They weren't going to positive infinity both going to positive infinity or both going towards negative infinity. Because of that, we can't say what's happening to this limit when we don't have either the plus or the negative up there as a superscript, because that left and right hand limit don't match, and so the limit won't exist even in the specific way. All right, let's also create a table for this. So when we create our table here, again, we're going to pick values on either side of 0. All right, so 0 is the value we're approaching. So we'll go negative 0.1, negative 0.01, negative 0.001, 0, we don't know. Then we will go on the positive side, to the right of 0. Okay, so if we plug in negative 0.1, we are going to get 100. Plug in negative 0.01, we are going to get 10,000. Plug in 0.001, the negative of that, and we are going to get 1, 2, 3, 4, 5, 6. We'll get 1 million. And we will get exactly the mirror image of this on the other side. Should be able to convince yourself. So you can plug those numbers in, but you could convince yourself of that, I think, because in this denominator, when we square that, squaring 0.1 and squaring negative 0.1, the negative is going to go away, and that denominator is going to be exactly identical on both sides. So that's why we're going to end up with these mirror images. We notice that as we are approaching 0 from the right, these numbers are growing very large without bound. As we approach 0 from the left, they are also growing very large without bound. So when we approach this from either direction, it is growing infinitely large. Great. In our next video, we are going to formally define an infinite limit, and then we will look at some more examples.